Alright, so this is part one of a three-part series on how to convert between grams and moles, moles and particles, really how we can relate masses of a substance to amounts, how many actual parts of that substance are there. So focusing just on grams and moles in this case, we'll just get right into it. So first example, we have a question, how many moles are equal to 25 grams calcium hydroxide? Two things you want to look for. First, what is the actual question here? And we get that in the first three words of the sentence. We are trying to figure out how many moles are present in the sample, what is our amount, and we also are looking for any number-based information. There's only one value here. The size of the sample in question is 25 grams, and it's calcium hydroxide. So you only have one number. We can only start with that number, so we're going to. We'll write this down. We have 25 grams, and the formula for calcium hydroxide, CaOH2. We'll put this over a unitless one. We're just trying to make it look like a little fraction. The unitless one does not change the mass. It does not change the units. It's just there again to make this kind of look like a fraction. So we're looking at grams and moles. We're trying to get moles from that. In any problem we come across where you see any mention of mass, or you get some amount in terms of grams, or you're looking for some amount in terms of grams, we are going to use molar mass. That is going to lead to using molar mass to solve this. Molar mass relates how many grams are in 1 mole of any substance. So the molar mass for calcium hydroxide should be available to you in assignment 6.1. But before we even solve that, let's just look at how the units are going to play out. So again, we're getting grams. We don't want to stay in grams. We want grams to cancel out in that next step. So currently grams are in the numerator. Well, to get them to cancel out, when we multiply through, we got to make sure they're in the denominator in the next step. And the nice thing, molar mass links grams and moles. We have a direct relationship there. So we can plug in moles up top because, again, we have a value that takes these two items and relates them. So for calcium hydroxide, hopefully you take a look at 6.1. You find out it is 74.1 grams for every 1 mole of calcium hydroxide. So that 74.1 is true for calcium hydroxide. It may not be true and won't be true for other elements, compounds, whatever. This is unique for calcium hydroxide. So I'm going to show the actual calculation. You don't have to do this, but I think it's worth looking at. When we run this through, you're multiplying fractions. When you multiply fractions, you multiply straight across and then you divide afterwards. So we have 25 grams times 1 mole, and I know these units might seem a little weird, but you'll see why I'm doing this pretty soon. We have 1 unitless 1 times 74.10 grams. So, and kind of silly that I'm including the ones in there, multiplying by 1 doesn't change the value of a number. But we do want to look at the units. When we multiply these and then ultimately divide, well, grams is on top, and grams is on bottom, and grams goes away. At the end of this, the only unit we have left is moles, which is important because that's what we're solving for. It should be the only thing that's left. And then finally, looking at the numbers themselves, 25 grams is definitely less than 74.1. And 74.1 is what represents 1 mole's worth of stuff. So we have a lot less than what 1 mole is worth, and we should expect having less than a mole of calcium hydroxide in the sample. That turns out to be the case. If you do 25 over 74.1, you end up, the sample is 0.34 moles of calcium hydroxide. And getting a little cramped in the corner here, but it's a good idea to include the number, the units, and the substance all in your answer. So, another example to show. We'll make this a little quicker. So this says, what is the mass of 0.48 moles of lead oxide? So same kinds of information, but we're kind of going the opposite direction here. In this case, we have the moles of our substance. We have the amount, but we want to know what that amount would weigh. If we needed 0.4 moles worth of lead oxide, how much would we weigh out on a scale? How we solve the problem doesn't change. We start off with the only number we are given, which is the 0.48 moles of lead oxide. We'll take this over a unitless 1. And now, applying the same kind of reasoning, we don't want to be in terms of moles anymore. We're trying to express this in terms of grams instead. So moles are going to have to cancel out. And since we're talking about mass, we can use molar mass. We can link these two things together, moles and grams. And for the lead 2 oxide, it is 223.2 grams for every 1 mole. That is the relationship here. So, not going to show the full calculation. This one's a little bit easier because, well, you have 1s on the bottom. If you multiply by 1, you get 1, and then divide by that 1, it's still the number you have. So our denominator doesn't really matter so much here because they're both 1s. But our units, moles, is on top and on bottom, so those cancel out, and then we just have to multiply our numbers in the numerator. So in this case, our sample is 0.48 moles. It is less than 1 mole. Well, based on the molar mass, 1 mole is worth 223.2 grams. So, we should expect a number that's going to be smaller than 223.2 because we don't have 1 mole's worth. We have, a fraction of a mole, 0.48. So you run this through, you multiply our top 2 numbers, and we end up with a mass of 107.14, if you round it 2 decimal places is fine, grams of lead oxide. And this makes a good amount of sense. We have a little less than 1 mole's worth in our sample. 1 mole weighs 223.2. Well, 107 is a little less than half of 223.2. So I think that is pretty reasonable. So we have one more thing to look at, but I want you to try that out. How many moles are equal to 200 grams of magnesium nitrate? This is going to be just like one of the previous 2 problems. Try to set it up, make that comparison, see what you get.